All right, here are some hints for lab L-7, which is Newton's particle theory of light. And so hopefully these hints will help you get started in the experiment. And so let me just start them out by looking at the lab sheet that you should have been given. Sir Isaac Newton said that lights, when they go, that particles of light, when they go from one material to another, like air to glass or something like that, will change the direction, as we're aware that they do, bending toward the normal, and also speeding up. His model could be demonstrated by this. If a ball is rolling on an upper surface, goes down a ramp to a lower surface, it is certainly going to speed up and change direction. The question is, does it change direction according to Snell's law? And that's what this experiment is all about, to see the consistency there with Snell's law and Newton's particle theory of light. And so here's how we're going to try this. So you will have a piece of equipment that looks like this. So the same thing that you saw on this diagram. We'll have on the upper part then a ramp, and the lower part is just the table. And as you see, what I've done, and I'll try to move this around a little bit, here is the upper part. I taped a piece of graph paper to this. Then here is the ramp section. So this ramp section right here will lead to the lower part. The lower part also needs to have a piece of graph paper. So I would just tape a piece of graph paper or just lay one right there. Then the launching device is this. So to achieve that launching, I place the launching device right here, put a steel ball on it, and it will roll down. Now that happened a little quickly. Let me try that again. Recognize that as it rolls down, it will go down the slope to the lower region. So here is the roller. We don't get a record of this unless we use carbon paper. So what we will do is put a piece of carbon paper on the top section. And remember, we will also put carbon paper down on the lower section. Carbon paper on the lower section, also on top of the graph paper. So in both cases then, what we will get is a record of the path of that steel ball. So again, I will put this up here. You can't see it very well, but you can see what we're going to do is put the steel ball on here, let it go down. Now what it did is it traveled, making a very faint path. And probably it's too faint even to see with the image, but let me show you how I can illustrate it. When you do this, you will be able to see some dots. Those dots will be faint, but they will be real. What I'm going to do is connect those with a straight line. This, like with light, is like a beam of light traveling. To find the angle of incidence or refraction on the lower section, all you have to do is recognize that because this is graph paper, it has a lot of normal lines. Those normal lines are all of these graph paper lines. And if you measure any one of these angles between the normal and the light ray, or the path of the ball, you'll have the angle of incidence. The same thing will happen on the lower section for the angle of refraction. So if you could get, say, 5 or 6 or 7 different angles of incidence and refraction, then that would be very helpful to make a data table. The way to do that is, this is one of them. Make the angle different. Make some dramatic angle differences, and that would help to do the experiment. The rest of it should work out very nicely. Hope it works for you.